So, where magnitude and direction cannot be characterized by a single number. That's our definition that we're looking at. Okay. So we have a directed line segment. We have our initial point and we have our terminal point. We'll be using these P's and Q's and stuff like that. So go ahead and make sure you have that written down. It does matter which one is your initial and which one's your terminal when they tell you you got to go with that. Okay. So the good news is this is nothing you haven't done before. You're like, I've never seen a vector. I've never done a vector. What do you mean I've never done this before? Or I've done this before. Remember good old slope and like the distance formula? That's what we're doing. Okay. You don't have to write this down, but I'm just showing you that the distance formula is the magnitude. Okay. And to find the direction, we're going to use the slope formula, but we're not going to write it like division. It's going to be written as a vector. Okay. So we're going to be subtracting our x values and subtracting our y values. And then it's going to go in where would an x normally go and where a y would normally go. So again, nothing you haven't done before. But to show that if two vectors are equal each other, we will solve the distance formula and the slope formula. If they're the same, they have the same magnitude and direction, which makes sense. I hate it when that happens. And as always, remember in the slope formula, you're already doing the steps inside the parentheses on the distance formula. So once we find the component form of a vector, then doing the magnitude is pretty simple because you just square them, add them, square root them kind of thing because you're already doing the difference between your x's and y's. Right. So this is what I mean by that. When they say to find the component form of a vector, we've already used these P's and Q's. We're going to use this line right here. So we're going to take our Q1, so our terminal x value, and subtract it by our initial x value. And then we're going to do our terminal y value minus our initial y value. And then it looks like an ordered pair, except now you have these what look like greater than or less than symbols. And yes, you have to put those new notations to show that it's a vector. Okay. So you take your terminal minus initial for your x, terminal minus your initial for your y, and then you have your component form of a vector. And trust me when I say this, all the notations and like formulas and stuff like that we're looking at make things look a lot harder than they actually are. It's not. All right, so I'm going to show you how to find the component form of a vector using Algebra 1 stuff, and then you could also use this as well. Does anyone still need that? Okay. So let's say I was to graph or plot the point 4, -7. That being my initial. And then I have -1, 5. And that's my terminal. Okay. So this is if I did it Algebra 1 way. From my initial to my terminal, notice how I have to go backwards. How much did I have to go backwards? So the first part of my vector is -5. Because I went backwards, it's negative. Okay? And then to go up, if it was on the line, which I went too much, is how much? 12. So not doing any kind of new stuff. And it's weird because we're so used to rise over run. I think that's the only part that might get a little tricky with that. But your x goes where like an x would go in an ordered pair, and your y goes where the y goes in an ordered pair. Okay? But if I wanted to, I could do the formula. So -1 minus 4 and 5 minus a -7, which also gets me -5, 12. Okay? So that's the direction of the vector. Magnitude is the distance. Okay? If I wanted to, I could do the distance formula, which in other words is Pythagorean theorem. You notice that's a right triangle. I'm trying to show you like old stuff you do know about in case you get on the test and you're like, I completely forgot how to approach these. You can, knowing old school knowledge. Okay. So magnitude, you're going to have these two lines on each side of your vector. That's how they denote magnitude. And we just take the square root. Like I said, we've already done the hard work here. So the square root of -5 squared plus 12 squared. Or if we did Pythagorean theorem, it would have been the same thing. Okay. Any questions so far? All right. Let's try this one.
What do you want our answer to look like?
I'm sorry?
What do you want our answer to look like
For magnitude?
for both?
So for the component form of a vector, you're going to write it, it's going to look like an ordered pair, but with,
Okay, so just put that, you don't want to do v equals that?
you don't have to.
Okay.
I'm
But
good
then
with just
for
that.
magnitude, it's the v and the 2 lines
Uh-huh.
equals whatever.
You can, yeah.
Okay, cool.
I'm not going to be picky about that.
Will they be picky about that? The STC test?
They as in it's a multiple choice test? Probably not.
Okay.
Yeah.
I forget those ones.
Yeah. No, it's, yeah, that one's just multiple choice. Not multi-select, not fill in the blank. It's like, now that was what it was before.
Yeah.
But I think that's what they said, too, that it's the same amount of questions and it's all multiple choice still. All right, so if I do this algebra one way, or if I just go ahead and subtract the two, doesn't matter. What's the x value, the difference between my x's of the first part of my vector? So -7 minus a -2. Okay. And 9 minus 3. So then again, I can find the magnitude by just doing the square root of -5 squared plus 6 squared. And you get the square root of what? 61. So whether they, like I said, it's a multiple choice test, whether they go ahead and find the square root of 61, they leave it as a square root of 61, you play their game, okay? Any questions on those? All right, so to add vectors, it's as simple as it sounds. We add the first part of each component together and then the second part of each component together, okay? Now, the next one that's down below, K would be a scalar. And if you remember scalars from matrix stuff, that if you have a number outside of a matrix, you just multiply it all the way through. Same thing, if you have a number outside of a vector, you just multiply it all the way through. So that's what K is. K is a scalar. All right. So, like I said, the generalization formulas and all the notations and all that stuff make it seem a lot harder than it actually is. So on part A, if I'm doing 2 times vector v, it's literally just multiplying 2 to each piece. To subtract the 2 vectors, I'll take w, which is 3, 4, minus v. And the only reason I'm writing it out like this, because when I did this problem the other day, in my mind on certain ones, I went ahead and distributed the negative, and then the other one I didn't. Okay, so writing it out like that will hopefully help, because then we have 3 minus a negative 2, and then 4 minus 5. And then vector v is negative 2, 5, plus 2 times my vector w, so that's 6 and now 8. So then I can add these together. So the operations, like I said, are easier than the generalizations that they give you. You say your friends hated this? It's so sad.
They were doing their homework with me, and I was just like, "What did you do?" We're doing 6-3. I was like, "Oh, fine." And they're like, "No, Okay.
Some of mine?
Mhm.
Huh. I wonder why they dislike it. Any questions so far? Am I making it like, am I like setting the bar low on it? Am I just like doing okay?
It's fun right now.
Okay.
We'll see how the textbook handles it.
That's
Hopefully the same.
Sometimes. Yeah, sometimes it's like way different.
Well, I do throw in challenge problems in there because that's just the nature of a honors
I feel
class.
like it
But
was that specific part that I was there for.
oh, I bet it's I bet it's this stuff right here where it's like,
It is.
yeah.
I remember.
I wouldn't stress about those. All right, go ahead and try this one all the way through. Thank you. Who wants to put up their answer for A? Okay. Who wants B?
I have to go up there and write it.
It's a lot of steps.
You gotta get your steps in for the day.
I'll get those later.
Yeah, he.
I got practice.
It changed the clicker.
What did it change to? Click the pin at the top. Oh, wait, change the problem or change? Okay. So click the top pencil or pins. Right there. And then pick a color. There you go. Okay. B. Who wants C?
Wait, is that right? No, it's not. Isn't it 0?
No.
Oh, that's right. Okay.
Believe in yourself, man. It's about confidence.
C?
Confidence in anything.
Ah.
Carter.
Thank Carter.
You're a real man.
Thanks, bro.
You're welcome, dude.
Speaking of Carter, have you done the Wordle yet?
No.
It's really frustrating, by the way. Unless you're lucky. It's very frustrating.
I got the last 2 letters right on the first one, and then haven't gotten anything else on the next 2.
It's frustrating. All right, any questions on this?
It's definitely.
No, the yelling was like
Did my head.
Okay.
So like that he thought it was a joke.
Wait, what?
Feel like it
Will
was
Smith
sweat.
slapped Chris Rock last night.
Oh yeah, I
That was
saw
weird.
something pop up about it, but I haven't seen like. Surely that's just acting, right?
Yeah,
I don't know. When he was
For
yelling, he
actor of
seemed
the
pretty
year, it
serious.
did look like
I don't know. When he first started yelling, though, he had like I don't know about.
they had to mute him, so like that's.
I feel like
They
guys.
did mute the audio.
I feel like guys when they're like doing stuff like that, they kind of like make it's something about their mouths that like make me think, okay, they're trying not to crack up right now. And I feel like right when he started, it looked that way, and then he got into like full blown character. Then
I mean, I think it was like Jada that shot him daggers. And like, I don't think he did it because he was actually mad. I think it's because his wife was like, why are you laughing? Because she was mad from the get go, and you can tell she was.
I know my best friend. She lives in Nashville. She loves all of the show or all the award shows and stuff like that. So I'm gonna ask her if what she's read or seen, if it was like legit or not.
Yeah, I got it.
Huh?
I got it. In 6.
In 6, yeah, I had it the last one too because it's literally like a ton of words could fit those letters. That's why I said it's frustrating. Okay, so unit vector. You're gonna put vector v over the magnitude, or you can put it out front like a scalar. I know it's behind it there, but out front technically is a scalar. So vector u has a magnitude of 1 in the same direction as vector v, then it's called a unit vector. Okay. Again, all of this stuff makes it a lot harder than it actually is. It's pretty straightforward once we do one.
Was that thing at the bottom?
Thing at the bottom, like the
Yeah,
paragraph.
Yeah, like what is that?
We're going to show that. So if we're looking at vector u and it's called a unit vector, it has to have a magnitude of 1. So that's what this is saying, that it has it. We're going to prove it that it does have that.
Okay.
But it's the same direction as vector v. Okay, so the vector u is called a unit vector with the direction. So again, it's
Okay.
trust me.
I'll try it.
All right. So the first thing I want you to do is find the magnitude of this vector. Okay. I've already got it in vector or component form. So find the magnitude. And then we'll verify. So just a heads up. So we're going to do 6-4 on Wednesday, 6-5 on Friday. We'll review next Tuesday, and you'll take the Chapter 6 test on Thursday. And we just have one more chapter. Isn't that crazy? That's so weird to me.
Yeah.
How long is the chapter?
It's not. I mean, it's because of the whole like AB schedule or HB schedule, and then also you got to consider we're out for 2 days for Easter, and then all that stuff. So
Yeah, that's
It's the 18th. That's the 18th.
15th is Good Friday.
but no, we'll have a good 1, 2, 3 review days before your state test.
When is our state test? Sorry.
No, it's okay. May
Okay, so it's in May, alright.
You would think it would make sense in May.
Well, yeah, but I've got like multiple ESCs.
But the algebra 2 is in April. May 16th
Okay.
at 8:30. We won't have a 7 a.m.
I've got an AP test the day of my show. I have to
Wait,
take an
what
AP
day did
test
you
and then go perform.
The 16th.
The 16th.
Yeah, there's senior exams that day
I
too.
have an AP test the day after my birthday. I just study on my birthday.
Thanks, get off on my
If my US teacher just go.
Okay. So to find the magnitude, again, we are going to do 7 squared plus negative 3 squared, which gets you square root of what?
58.
50 what?
8. Yes.
I had to think about that there for a second. I kept on wanting to think 59. Okay, so that is our magnitude. All right, so we are first going to make it into a unit vector, and then we're going to verify that it has the magnitude of 1, okay? So once you found the magnitude, we are going to multiply that because it was 1 over that, and we'll rationalize later. We're going to multiply that through. So technically, still not our final answer, but we have 7 over the square root of 58 and negative 3 over the square root of 58. All right, so if we rationalize that, and again, hopefully we've rationalized enough to know that it's just going to be 7 square root of 58 over 58 and negative 3 square root of 58 over 58. Oops. Okay, so that is your unit vector. Okay. We found that by taking the magnitude and doing 1 over the magnitude, multiplying it to the vector, okay? Now we have to prove that that has a magnitude of 1, okay? Personally, I don't want to square these. Not what I'm into, okay? So why don't we, yes, we've already got the first part of our answer right here. Why don't we square this? Which is a whole lot more appealing. Because if you square a square root disappears. Okay? So if we take the magnitude and I do 7 over the square root of 58 squared plus negative 3 over the square root of 58 squared. I get 49 over 58 plus 9 over 58 was 49 plus 9, 58 over 58. And the square root of 1 is 1. So we just verified that we, it's kind of like when we did those, so that's why so this is the thing. Remember when we had those problems for the inverse? And I told you to find the inverse. And then in the book it says now verified that that's the inverse. So you had to do f of g of x and g of f of x. And you're like, well, it worked because I found it. Well, the same situation. We found it. We're proving it. It's what they're asking us to do is what it is. Okay. So, step 1, find the magnitude, multiply it through, rationalize, and then find the magnitude. Okay? Or prove that the magnitude's 1. Sorry. Okay, try this one.
think it might be the first math class that has ever actually gotten me to run out of a college note paper.
That it what?
Like I'm almost out of paper. That's never happened before.
You've had me before.
I know. Exactly.
You should have gone through it.
I had like at least a quarter of my Algebra 2 notebook left.
Really?
Yeah, I did too. I've got half of this one.
That's crazy. I would have like the big ones. And it wasn't that I wrote big. It was just I had all the things.
You wrote it.
I wrote all the things.
What time is the Oscar tonight? Is it like the Oscar? No, that was yesterday.
What time was it at?
Yeah.
It's usually in the evening, like what
6 in the morning.
7 or
It was enough that I got the notification at like 8:30.
oh.
So
The video got slapped.
yeah,
Was it in like his opening?
I
It was in his
don't.
monologue. Yeah.
I don't watch the Oscars. I just know that I got the notification. What happened to the Oscars? And I was like, I don't care. Anyway, so yeah. And I saw the video this morning, and I was like, oh, I should have cared.
Yeah, there was just like all these like memes already, of course, about Fresh Prince of Bel-Air. What did y'all get as your magnitude? Well, the square root of.
Either it's fake or Chris Rock has the jaw of steel. He literally was saying, "Oh wow," right after he got hit.
Yeah, he was unfazed.
Like he was laughing as he was getting hit, so he obviously did not get hit. Because Will Smith's a big dude.
Okay, so what was it again? Square root of? That's where my, is that where my 9 was coming up? Yeah, that's where my 9 was coming from. Okay, square root of 29. All right, so then from there we have -2 square root of 29 over 29. Like I said, hopefully we're getting into that habit where we can jump to some of these things. If not, if you need me to work the what I call the slow-mo version, I can. And then to prove that, we're going to take the square root of -2 over the square root of 29 squared plus 5 over the square root of 29 squared. We get 4 plus 25, which is 29, and 29 over 29 is 1. Square root of 1 is 1. Okay. Questions?
Will we encounter an instance where it does not equal 1?
Then you did something wrong.
Okay.
It's different if I told you, hey, this is the unit vector, not find it first, then prove it. But if I told you, like, this is it, prove now that is that a unit vector or not, then that's when you probably run into it, or you made a mistake. Okay? All right. So, again, this is another one of those situations where it's going to seem a lot more difficult than all of this up here. But go ahead and get this in your notes. Unit vectors 1, 0, and 0, 1 are called the standard unit vectors and are denoted by I and J. Do not give the extra little curly Q with I, because then that'll mean like it's imaginary. Just do a straight down I. You have vector V, so your V1, V2. And you're going to have what's called a linear combination. And that's the first part of your vector with I and the second part of your vector with J. And like I said, it is a whole lot more difficult looking at that than it is actually doing it.
So like V1 and V2 are gonna be numbers, and you just multiply like the vector by the number, and then add them.
It's literally going to be, if I have a vector 3, 4, it's going to be 3i plus 4j. That's why I said it's that makes it look a lot more difficult than it actually is. A linear combination is just like another way that we'll write them, because you'll see that written more like when you go into calculus and stuff like that. And they actually use little hats. But we're not doing the little hats.
How much time do we have like after our challenge exam?
Not much. Like a few days.
Is it the 18th?
Yeah, because I think we have, and especially with the alternating schedule, I can't remember. I think I have y'all for maybe like 2 days.
It's a 500 point extra credit assignment.
Let's do it.
Can it be writing your name on a piece of paper?
Yeah, you show up that day.
Can it be writing your name?
That's a
on
lot
piece
of
paper?
incentive for
You
me to
spell
show
the
up.
word
So not
correctly.
only do y'all want me to give you the opportunity to get a 500 extra credit point assignment, but also to make it uber easy?
Yes.
Yeah,
No,
of course. Writing's difficult.
no,
It's the last days.
no.
You know?
Y'all are greedy.
What if we wrote you a math essay?
I mean, I would.
Okay,
I would settle
You
for
know
it.
me,
Yeah, but what if I like wrote it in binary?
but you know
Is that
me.
different?
You know how much I love reading.
That's a number.
So why would I want
What if I
10
made-
papers
In
to
binary?
read?
Did you give me 500 points? I proved my.
What if I made the
No.
paper like a word problem?
Like what? Yeah. What?
What if it was just a big long word problem? and you
What if
had
I
to solve it?
proved that I'm not as good at math as I thought I was? What if I proved that?
What if you verify
You
it?
you
What if
I can verify that very easy.
No.
Made it a puzzle.
My
Yeah,
ego
what
is
if
definitely
you wrote
bigger
some
than my
algebra
skill.
equations? Like a certain letter is a certain number.
Ego.
that's a discussion
Brackets.
later when it's
Skill.
not around everyone else and recording.
I don't care.
All right, so linear combination. To first find the component form of that vector, I'm giving you the point, the terminal, and the initial. So this is a review back from what we learned at the beginning of class today. Turn it into the vector, component form of the vector. And then we're going to change it to a linear combination.
Harder has gained consciousness. I see that.
Is that your explanation?
Write you as a linear combination of these two vectors. Whatever that means.
So my terminal is -1, so -1 minus 2 gets me a -3. And 3 minus a -5 gets me 8. Okay? That's the component form of a vector. Linear combination. -3i plus 8j. Done.
What movie did he win Best Actor?
Oh my gosh.
Who?
Back to Will Smith.
Richard.
Was that why he said that? When he was walking up, he said, "Oh, King Richard," because like Chris Rock was like, "Oh, is that what he said?"
Maybe. Is that what the movie was for? don't know.
I say we just
don't know.
review the film and we consider
Yeah, I wouldn't
Sure.
lose.
frame by frame.
Maybe they're
Wouldn't
right.
lose my job for that.
Why would you?
Yeah.
No one will tell.
Oh, I forgot this was recording.
Yeah.
You can stop recording. It's fine.
Does anyone have to?
All right. Do we need to do another one of those? Okay. All right. So you can also do operations with these. They are as easy as they look. Okay. I'm going to take 2 times my linear combination. Linear is it combination?
Yeah, it's a combination. I thought it was.
Yeah. I don't know why that didn't sound right when I said it. Okay. So we're going to multiply 2 times u. So we'll get -6i plus 16j. And we are going to subtract that with 3 times b. So 6i minus 3j. So -6 minus 6 gets me a -12i. And 16 minus the -3 is plus 19j. So operations are still the same. And again, in the world of vectors, we are just more of the computation in this world. You're going to take it further, whatever math class or science class you continue on next to. Okay.
How complicated do vectors get at like higher levels? Or are they always?
I can't remember, to be honest, like when I actually went through it. And that's one of the things that I want to start teaching calculus, because I want to know those things. Like I can sit in algebra 2 and all day, every day say, this is what it's going to be like when you get to pre-calc, because I know what that's like. But I've never taught calculus. I took it, but I never taught it. So
What in like calculus kept you up at night? You know?
what thing in calculus kept me up at night? Nothing. And that's not because I'm a math person or whatever. Now, if you give me all the analysis classes, now those kept me up at night. No, that's when I had that. Calc 3 was when I had that professor that taught with 3 pens from his desk, sitting at his desk. And he was like, well, if x equals this, y equals this, z equals this, then this. And we were like, can you write it down on the board that's behind you? And no, just taught it from his 3 little pens that he had in his hand.
Is that paintbrush?
So guess who taught herself calculus 3? This girl. Yeah, that's paintbrush.
Will you go back for a second?
Uh-huh. Did I add wrong?
I think it's negative. Oh, never mind. I was doing something. Nothing.
Okay. No, it's totally possible that I could have added wrong. Okay, so direction angles. So we already know that our x is cosine, y is sine. If we have vector u, we're going to find theta in all of this, okay? And we're also going to use this same process in 6-5.
How do you get in a circle? How does one draw a circle? feel like you has been like 7 different things already. It has. So I think there's enough.
I feel like there should be 2 letters.
So if we're in the unit circle and we're looking at those vectors, we've got cosine, sine, just like we did before. It's a linear combination, cosine I, sine J.
Circle.
You drew the circle?
Yeah.
This is this like the last thing in this? There's like 6 different operations we've done today.
I'm starting to see why
And why
my
are you
friends
finding
did.
theta again? I just had a whole unit on finding theta.
Like, I'm okay with it right now, but I can understand why.
No, this, no. You will need a calculator if you don't have one.
Right now.
All right, so if you notice, x value, y value, the component form of the vector, cosine, sine, so on, okay? So if I give you the linear combination, I want to know the direction angle for each vector, okay? So this is like my x and this is like my y, correct? If we were looking at the last slide. So what if I graphed 3, 3? Or plotted, okay?
Yeah.
What's theta?
It's, yeah.
8 plus square root 18. That's what it is.
And I'm going to show you how to do it. This is the only one that I'm like, what's theta? The other ones I'll show you how to actually. Huh?
Square root of 18.
No,
Why not?
theta,
What do you
not the side.
45.
45.
Oh,
So,
What'd you say?
45.
No, you didn't. What'd you say?
that's what I said.
No, he told us that. He actually said
45 degrees, because if we ask the question, where is tangent 1, right? 3 over 3 is 1. So you're looking at an opposite and adjacent. So on all of these problems, you're going to do the inverse of tangent. And in this case, like I said, this was the only one that I was going to make you solve without using a calculator, just because we know where tangent is 1 in that first quadrant. The only problem that you're going to run into with these is that's why I have you plotting the point first, because your calculator is going to give you an answer. And remember, your calculator, when you type in the inverse of something, there's still 2 options as an answer. The calculator is giving you one of them. So you have to plot that point, and whatever answer they give you, you might have to use what they give you, but then also to make sure that is accurate where it is. Okay, again, it'll make sense in a second. You won't have any negative angles, you'll have only positive, because it's direction. So let's look at part B. If I plot 3, negative 4, I'm going to do the inverse, negative 4/3. sure you're in degree mode. So the calculator gives you negative 53. I said no negative angles. So what do we do?
Add 360.
At 360. So theta is 306.9 or whatever they asked you to do. So yes, that is accurate that is negative 53. But again, where we're located, that's where we got to keep that in consideration. Okay. Let's go ahead and try C and D. And we're going to be using this same exact thing in 6.5.
You always have to subtract it from 360.
It depends on where you're located. Sometimes it's 180.
You want us to do D?
Yes, C and D. C is also one you should know because it's on the unit circle. Oh gosh, that scared me.
I didn't mean to scare you.
What just
There's a fly.
Oh, I just came out of my skin again.
I'm sorry. I wasn't trying to kill you either. There was a bug.
Oh, say bug next time.
Okay.
Oh,
You might hear me.
But the people,
I will hear you.
Well, he might.
I bet the people watching are loving this.
Oh,
Oh, yeah.
But that's gonna be on the news next.
good morning.
Oh. Teacher literally scared out of skin.
I'll come down from that in a second.
Oh, really?
I don't know. My heart's racing. Okay. So negative 6, 6 is up here in the second quadrant, which is if we were going to find the inverse of tangent at -1 or of -1, we should get 135. The calculator probably gave you something different. What did it give you?
350. All right, now negative 45.
Negative 45, which is totally fine. If you notice, negative 45 would be down here, right? So then to find that, you notice that's 180. You can look at it that way. So 180 minus 45 is 135. That's why it's really important to plot these. Okay. And over here, if we have -7, -4, we are down here in the fourth quadrant. And when we type that in, what do we get? Depending on how many decimals, that's how you to round to, so 209.7 or 210 or whatever. Okay.
What?
It's just 29.
Yeah.
Yeah, you add, and then you add 180, right? Is that what that is?
Hang on.
It's 29.
Why are we adding?
So inverse -4, -7. Yeah, the inverse of -4 over -7 gets you 29.7, right? And then you add 180 to that.
So, yes.
So 180 plus 29.7 is 209.7.
How do you know when to add 180?
So when you're looking at it where I'm located, this is 209 degrees, meaning, so this right here is the 29.7, so I added the 180 with it.
Yeah, and then you subtract 180 on the last one. And then, what, you subtract 360 on the other one?
Okay.